In this segment, we are going to study about potential energy of system of charges. In standard 11, you have seen or you have already understood that the energy and work both have the same dimension. Over here also, we have also discussed that U is equal to Q times V. That means charge multiplied by the potential of that particular field is equal to the potential energy. Potential energy is also equal to the work done. Work done in building up charge configuration Q1 and Q2 initially at infinity. Consider that these two charge initially was at infinity and we are trying to bring these two charge at given configuration. That means Q1 at position coordinate R1 and Q2 at position coordinate vector R2. To build up this particular configuration, the amount of work done that we do is exactly equal to the potential energy, which is the energy. Whatever work we have done is being stored in the form of energy, and that energy is called potential energy. So, the work done in bringing it to given location. So, first of all, try to remember this. No, you should remember this. That in this present situation, there is no other charge than Q1 and Q2. So, work done in bringing Q1 from infinity to position R1 is equal to 0. Why so? Because there is no external field. So, we are not supposed to do any work against any kind of force. And therefore, bringing this charge, work should be 0. Because F is equal to 0. Because of absence of external force. Next is potential due to charge Q1 at R1 is equal to. Now I have bring this particular charge Q1 from infinity to position coordinate vector R1. At this particular point, it has potential V1 is equal to 1 over 4 pi epsilon naught Q upon R1P. We are just saying that at infinity there is a point P, and from point P we are bringing this charge up to a position coordinate R1. Work done in bringing Q2 from infinity to vector R2. So, here, first of all, we bring the charge Q1 and there was no external force. But right now, we have an extra charge Q1 which is eventually going to apply force on charge Q2. So, now we cannot say F is equal to 0, but we say F is not equal to 0. In this case, work done, which is equal to force into displacement, we are supposed to bring this charge in such a way to oppose this particular force. So, from infinity to R2. Okay, so this is the potential is there already. So, this should be multiplied by the charge Q2. So, basically this one equation U is equal to, suppose Q2 we are bringing Q2 into V1. So, due to V1, this is the potential that should be multiplied by charge, and then we are getting the potential energy. the distribution of three charges Q1, Q2 and Q3 and the work done in this configuration. So work done in bringing Q1 at R1 is equal to 0. Next is work done in bringing Q2, work done in bringing Q2 at R2. This work should be in the opposite to the potential due to this. So I will say Q2 into V1. So Q2 as it is V1, potential due to Q1. So that is Q2 Q1 upon 4 pi epsilon naught. And of course the distance between these two is going to be R12. For Q3, work done in bringing Q3 is equal to Q3 into Q1 due to Q1 the field upon 4 pi epsilon naught R13 plus Q2 Q3 multiplied by Q2 upon 4 pi epsilon naught R23. R23 is the distance between Q2 and Q3. R13 is the distance between these two. That is okay. So total work done is equal to Q1 Q2 upon 4 pi epsilon naught. Let's not just write that plus Q3 Q1 R13 plus, let's keep it this way. Instead of this R, I will write this particular R. So, okay. Plus Q3 Q2 upon R23. And we have taken a common 1 upon 4 pi epsilon naught. So this is our answer. Okay. So you can either take it this way or the given in your text. Whatever method you choose, it is right. But for me, it is more convenient to write in this particular manner. And by writing in this particular manner, it is also easier for you to understand it. So that's all. Now, potential energy is a characteristic of present state. That means it does not depend on which path the charge has followed or which way a path was better or anything like that. So it does not depend on the history, but it depends on the current configuration. Okay? Example number 2.4. 4 charges are arranged at the centers of square ABCD of side T as shown in figure 2.15. A. Find work done required to put together this arrangement. B. Charge Q0 is brought to the center. So this is the charge Q0 which is brought to the center of the square. 4 charges being held fixed at its corner. How much extra work is needed to do this? So, first of all, let's just say we are bringing this particular plus Q charge. So, 1 done in bringing plus Q charge at A is equal because no work is required, because there is no external force which is acting on it. So we are not supposed to do any work. Next thing, work done in bringing minus q charge at B is equal to 1 upon 4 pi epsilon naught minus q, and let's just say 1 upon 4 pi epsilon naught. फिर देख this one, q upon distance between these two charge A and B. The distance is B, so I will say the field due to this, that should be multiplied by charge, which is minus q. So I will get minus q square upon 4 pi epsilon naught d. Now work done, same work done in bringing plus q charge at C is equal to. So over here two forces are going to act on it. One is due to A, which is on this direction, and other one due to this. B and A both are going to apply certain force on this particular charge. So let's just say charge due to Q1 is plus Q upon the 1 upon 4 pi epsilon naught. Okay. Charge on C is what? Plus Q. Now charge due to B is what? Minus Q upon 4 pi epsilon naught. Okay. One thing over here. This cannot be, because B would be either if it is in this direction. This is a since it is a square, so all angles are right angle, and this is the hypotenuse of this right angle triangle. This one is d square, this one is again d square. So b square plus c square is what? 2d square. So under root 2d is the distance from A to point C. This is going to be d, because straight line joining B to C is distance is d. So we substituted over here. Okay, this charge should be multiplied with charge on C, which is plus Q. Okay. Done. Next is work done in bringing charge minus Q at D. At point D we are bringing. So over here the potential due to A is also going to affect, potential due to B also going to affect, and potential due to C also going to affect. These two, for these two, the distance is going to be D. So I will write that particular thing right now. 1 upon 4 pi epsilon naught A charge plus Q upon D. That should be multiplied by minus Q plus